yesterday. How many people brought their note cards with you? Now, that whole thing of doing the scavenger hunt, there is a purpose behind it. The purpose is not finding where the other team went. The purpose was coming up with a method of doing it. Let me ask you this. If we would have done the same thing, but we would have done it out on the baseball field, and I said you had to stay inside the baseball field, would it have been easier? Why? Because there's no walls. No matter how you added them, no matter what order you did them in, you'd end up at the same place, right? But here we've got walls being constriction. That's why we don't do it outside, because we want the walls in the way. But the point is, it doesn't matter in the order in which you add them. Correct? So, let's see if we could figure out a way in order to add them that would make things easier for you. If, let's say, for example, that you have in your stack of cards, let's just go on a page here. You had a stack of cards, one of which said 5 meters east, and another card 5 meters west. What can you do with those two cards? Throw them away, because they cancel each other out. You'd end up back where you started. What if you had two cards 10 meters north, 10 meters south? Cancel. Toss them away. What if you had three cards 10 meters east, 8 meters west, 2 meters west? They cancel again. What am I doing with these cards? I'm not looking at them as a whole mishmash of them. I'm looking for ones that all act in the same direction, and can they cancel out with ones in the other direction? So let's say that leaves me with two cards, 8 meters west, 5 meters north. I've canceled out all my other cards. I end up with this. Where is my spot located? 8 meters down the hallway, 5 meters toward the office. What I've done is I reduced that entire stack of cards down to 2. And that's the easiest way to do that whole problem, is to take all your stack of cards, look at them, take all the easts and wests and combine them together. Will it come up with 0? No, probably not. But it'll come up with maybe 20 meters west. Most people ended up over on that side of the building. So 20 meters west, if you take all your north and south ones and add them together, you're going to come up with some value probably north. And there you are. Now, could you necessarily walk directly there? No. Because as you walk down west on this hallway, eventually you run into the cafeteria, the lunchroom. But let's say that you had to go, 40 meters west, and then 15 meters north. That would put you about probably in the trophy cases over there. Let's say it's 20 meters to the cafeteria. Now you're going to end up going north anyway. Go a little bit north now already, and then head west. So instead of starting here and doing this, you could start here, go west, take a little jog, and end up at the same place. Now, could you take those cards and reduce them down to one card? one new card? Sure. In this case, it would be right there. You had to go northwest. Now the reason I said no northwest, no northeast is because it makes everything a little more complicated. You can't cancel out as easy that way. Now exactly what am I talking about here? Vectors. We are going to concentrate on vectors for a while. Now we have talked about vectors already. Vectors have magnitude and they have direction. 50 meters northwest. Or in our case, it was 50 meters west or 10 meters north. Those are vectors. Now, have you dealt with vectors in math before? Yes. So what do you know about vectors? They can be added or subtracted. We typically add them. And they can be added in any order. It doesn't matter the order that you add them. In our case, we wanted to go west and then north, west and then north. If I go north and then west, do I end up in the same place? Yes. Doesn't matter the order in which you add them. They are independent of each other, in other words. When you add them, they are independent. They act separately. Now, one type of vector is a distance vector. How far you are and what direction. In this case, we were talking about direction and distance. Now, realize compass directions are actual quantities. And they will state compass directions in the problems. I'll talk compass directions, so I got to talk about them a little bit. 45 degrees north of east. When we talk about compass directions, we have to define what the direction actually is. Northwest is not good enough. Because for most people, northwest is a general direction. For me, it's not. Northeast is a general direction. For most people, it's kind of off in that direction. But technically, it's not. Northeast is technically 45 degrees north of east. In each of these cases, what you have to do is you draw a coordinate system. North, east, south, and west. If I want to represent a vector in each one of these directions, 45 degrees north of east, in order to find that, I'm going to start at east, and I am then going to go 45 degrees north of it. So 45 degrees north of east would be halfway between north and east, and it would go off in that direction. Now notice I don't have a magnitude on there. I'm just going to talk about direction here. What would be another way of stating exactly the same direction? East of north. 45 degrees east of north is exactly the same thing. It depends on which angle we're talking about. Are we talking about this one? That's 45 degrees north of east. This is east of north. You come up with the same thing. 15 degrees west of south would be where? Let me write down in here where this angle is 15 degrees. It's west of south. What's another way of stating that same direction? 75 degrees south of west. The two have to add up to 90 degrees. Typically, when we state directions, we take the smaller of the two. Not always, but typically we do. 30 degrees north of west. In here, where this angle is, 30 degrees. What? That just shows the direction. It doesn't matter either size. Usually you don't have a complete arrow. You have half an arrow for a vector. I don't know. Ask a math guy. It has to do with rays and things like that. All right, so we good on those directions? East, southeast does have is an actual value too. East, southeast, what would that be? It would be east, southeast would be east of southeast. You're right. So if this is southeast, east, southeast is going to be in there, which is going to have a value. So what's this angle in here going to be, do you think? 22.5, half of 45. It does have an actual meaning. Typically, though, we want to be stating degrees, just so we make it more obvious. Adding vectors. We can do it graphically. And graphically, you take and you measure out your vector. So I've got 25 meters west. I pick an origin. I'm going to make my origin right here. I'm going to go 25 meters west and then 40 meters north. What do I then have to do? I come up with a scale. Let's say that every two lines is 5 meters. 1, 2, 3, 4, 5. So I've got a vector that goes this direction. 40 meters north. Is that it there, I think? My sum is that side right there. What is the word that we use for the sum of two vectors? Nope. So you add two vectors, what's the result that you get? The resultant. I tried to not use the word result, but I couldn't do it. It's the resultant. That's what you get when you add two vectors together. Now, when we add two vectors together, how do we have to do it? You're at head to tail. You go to the end of the first vector, and then you start your second vector. Head to tail is addition. If you think of this physically, because if I'm not careful, I've got 25 meters west and 40 meters north going like that. Does that add those two vectors? No. That does not add the two vectors, that one and that one. Is there any physical way I could actually walk that path? No. You have to think it physically. It has to have a physical meaning. In this case, 25 meters west, 40 meters north, this would be like you're outside somewhere and you rock 25 meters west, 40 meters north, you end up at a place. The question would be, how do you get home? How do you get back to where you started? Well, you could go 40 meters south, 25 meters west, but what's the shortest route home? Along the resultant. That's going to be shorter than the two sides added together. And we could actually take and we could measure this, physically measure that distance.